Okay, folks, so this assignment 2.2.2 is about NAND universal gate. It's a new gate we haven't talked about yet, and it says it's going to save you money, and we'll see why in a minute. First off, what does it look like? It just looks like this thing, and which looks like an AND gate, A-N-D, like a regular AND gate, except with a bubble in front. And the bubble kind of like inverts it. So think of a regular AND gate, and then whatever the answer is over here, it's going to get inverted. And that's why if you look at the Z, the output here, it's the exact opposite of an AND gate. Remember, an AND gate, you need both these inputs to be a 1 for this to be a 1 right here. So both these have to be a 1 for this one to be a 1. That's the only way on an AND gate. This one and this one have to be a 1. But that, a 1 and a 1, will result in a 0 here. All the other ones are a 1, so it's the exact opposite. On an AND gate, you would get 0, 0, 0 on all the different combinations, and only a 1 right here if both these were 1. But this is the exact opposite. This is a NAND gate. We're never going to use it as a NAND by itself. We're actually going to use something called substitution, where we use these NANDs to make ANDs, ORs, and inverters. So watch this. If you take the inputs, the two inputs, and you wire them together, and you just run one wire to it, you get an inverter. It actually acts like an inverter. So just know that. And if you take a regular NAND and you put one of those homemade inverters right out of a NAND gate, technically you're inverting that inverted and it just inverts back to a regular AND instead of a NAND. I know that sounds kind of confusing, but you just get an AND gate. Now, kind of weird, and it sounds totally like a waste. You're probably might even thinking right now, why would I do that? I'll just use an AND gate, because then I'm only going to use one gate. And you're right. In the end, you're kind of wrong, but you're right in looking at that going, hey, I could just put one logic gate and AND gate. Why do I need two of these things? That's a waste of time. And, as of right now, you're right. And then you're definitely right if you're thinking that now. You're looking at this and going, how do I make an OR gate? I need to make two of those inverters, the NAND inverters, the ones where you tie the back end right here, or the inputs, and you tie them together. You got to do two of those and feed them into another NAND. That's three NAND gates. N-A-N-D. Remember, NAND means not and. So these NAND gates, you need three of them to make one OR gate. But it works exactly like an OR gate when you're done. But what a waste, right? I know you're thinking that. Here's a little cheat sheet. You might want to take a screenshot, pause it, write it down in your notebook, take a picture with your phone, whatever. This is it. An AND, you can replace it with this. Two NANDs. If you have an OR, you can literally just replace it with three NANDs. And if you found an inverter and you need to replace it, you can replace it with one NAND. So that's how these are the substitutions down below. You would replace these up here with them. And that's why it's called a universal gate. You can actually use them as any of these. You just need kind of more than one to do it. You can pause this and read this if you like. I'm not going to bore you with that. So let's just look at one circuit right here. Here it is. We have an inverter coming out of C. So we got three inputs. We got one output. We have one inverter, which is a 74LS04. We have two of these AND gates, 74LS08s, and one OR gate, a 74LS32. Pretty simple looking circuit, nothing crazy, and it's not too hard. But I want you to think, how many integrated circuits, the little black integrated circuits that have all the little pins, looks like a little bug, and you stick it into the breadboard, right? So how many 74LS04s would you need? Well, I'll have to go get one out of the tray, right? If you're going to build this, you would need one integrated circuit for 74LS08, and you need one for the 74LS32. So you need three different integrated circuits here. One of the ORs, one of the ANDs, and one of the inverters. Now, you're not going to use all of them because each one of those have at least 4 gates inside of them. You're only going to use one of these, and you're going to use half of the AND gates. The inverters have 6 gates inside of an inverter. You're only going to use one. But still you need 3 integrated circuits. So what if we substitute? What if I take that inverter and I put this NAND? So I put this NAND gate. Okay, because I could just do that and substitute it. And these two AND gates, I'm going to substitute these, right? Remember, that's how you do an AND gate. And this one OR gate, I got to put this big monster thing with 3 gates. That's how you substitute an OR gate. We already went over that. And you put that there instead. Now, it looks like more gates, and it is, right? It's more gates now. But look at this. 1, 2, 3, 4, 5, 6, 7, 8. 8 logic gates, and they're all the same. So I could just go grab 2 NAND gates, integrated circuits, and you've saved money, you've saved time, and a little bit of space. Maybe not time, but you've saved some space on your breadboard, right? So if you're designing a toy, you just saved the company a lot of money. They don't have to buy 3 different gates. They can get a deal and just buy a bunch of NANDs and do the exact same thing. And plus, using one less integrated circuit. Remember the other one, we needed an inverter, we needed an AND, we needed an OR. We needed 3 different integrated circuits. This one, you just need one type, the NAND, and that's it. But wait, there's more. You could even save more. Because look this, we're going to zoom in here real quick. So watch the screen here. This right here, remember this one right here was an inverter, right? That was an inverter, we substituted it. But this here is an AND gate. That's how you make it, an AND gate. But what is that by itself? It's kind of like an inverter, right? Same thing with OR gate. This is an OR gate, this big thing here. Let me zoom out a little bit now. This whole thing is an OR gate. But if you look, this by itself is sort of like an inverter, right? That's kind of how you make an inverter. You know, you tie the back end, the inputs together, and you have the one wire going in, one wire coming out. That's an inverter, and that's an inverter technically. I know it's part of the AND. I know this one's part of the OR, but they're still, all they really do is invert. So if that's all they do, you're inverting and then inverting back, you can cancel these out. You could just say, hey, I don't need those. They're just doing inverting and then inverting right back, technically. And then you have this, one single integrated circuit, all the same gate. So yes, it saves money and it saves time. A little more work on your half, but you're definitely saving time and money. So your assignment is going to be 2.2.2, which I'll be going over next. So that was just an introductory of the NAND gate. I hope you took some notes and you learned something there. And next I'll show you what you have to do for the assignment. I don't want to make these videos too long. So the next one's going to explain how to do your assignment.